Now, we're not going to really delve straight into rational functions just yet. We're going to talk about variations, indirect variation. Now, direct variation, it kind of talks about that. You've already seen it and kind of heard about it. But direct variation is really saying that two things, x and y, very directly means that, or the equation version is y is equal to a times x. And a is just going to be a constant term. It's just a number. And when we talk about something very directly, as one increases, the other increases. It's direct. It varies directly. One goes up, the other goes up. Well, if one goes down, the other goes down. Now, we could consider this kind of like, well, I have pop figures. And the price of pop figure, I mean, if you buy it as a release, it's about $10 a figure. They're normally about $10 a pop. Well, some of them, if you go to, let's see here. If anybody knows what that actually stands for, or it's not DC, it's CC. CC, San Diego Comic-Con, or any kind of Comic-Con, they'll release special edition ones, which probably you can pick up for about $10 a pop. However, they don't stay that way, because again, they're rare, so the more rare they are, the higher in rarity, what's going to happen to the cost? It's going to go up. They have some of them that they released that are now worth over $300. So again, kind of that direct variation is something, one increases, the other increases, or one decreases, the other decreases. Now, we could manipulate this equation and get a by itself, so y over x is equal to a. I mean, these here are the same equation. I just kind of rewrote it in a different way. So we have direct variation. Y is equal to ax, or y over x is equal to a. Could I have it as x over y? I mean, what did I do? I flipped the x and y, so what would I do with the other side? Oh, we could flip it, right? Because we talked about fractions, how we can flip one and flip the other, so it's easier to kind of work with. Proportionality. Well, what is a? A is just a, what? Number, right? It's a constant. So can fractions be constants? Are fractions just numbers? Well, yeah, anything can be a number, right? So is this here the same? Or we wouldn't really use equal, but can I write 1 over a the same as a? Yeah, because they're both just numbers, right? So really, I don't have to write this as x over y equals 1 over a. Just a. This is kind of one of the many aspects, it's not something that we normally get into, of constant terms. Does this flipping it change what it's equal to if we had this set up to equal to a value? Well, yes. But since we're defining it as just a constant term, whatever the value of the constant term does change, but it's still equal to a number, it's still equal to a constant, yes? And that's kind of one of the interesting things with constants. We can manipulate them this way. Because again, any of these here, we're just relating x and y. As one increases, the other increases. It's just talking about that relationship. And how it's represented is going to be kind of in one of these ways here. We can get it in either any of these here. And between these two here, I mean, we can manipulate the bottom one to get to the top, or I can manipulate the top to get to the bottom, yes? If we wanted to, we can manipulate it and get it into one of these three forms. Now, inverse variation is saying y is equal to a over x. So if direct variation says one increases, the other increase, or if one decreases, the other decreases, what do we think about inverse variation? What's happening there? Yes, as one increases, the other decreases. They're going opposite directions. Inverse variation. Inverse variation is actually easier to think of examples than it is for direct variation for some reason. If we think of inflation rates with money, is as the inflation rate goes up, the actual value goes down. And it's just talking about things going into different directions. A pulley, because as you pull one side down, the other side goes up. And as the number of pulleys that you use increases, the actual amount of work needed to lift it goes down. Now, again, we can manipulate it just like we did with the other equation, and we can multiply both sides by x and get yx is equal to a. We can get both of the variables on the same side. So these here are the same equation. Any questions on this here with inverse and direct variation? Are we good with these here? Okay. So this example one, is really what we're going to stop with today. We'll do this today, then we'll finish this up tomorrow. Now, what we're wanting to do is to tell whether x and y show direct variation, inverse variation, or neither. We want to see which one of the three it is. Now, if I look at the first one, we have x times y is equal to 5. So would that be direct, inverse, or neither? It'd be inverse, yes? And why would it be inverse? X times y equals a. That's one of our ways that we can have this. Now, another way we could have looked at is we could have taken this here, x times y. You don't have to write this one down. This here, well, if I get y by itself, well, I would divide both sides by x, and I get y is equal to 5 divided by x. And again, that's our inverse variation. So really what I'm looking at is, can I see, is it set up as one of our different forms of inverse or direct variation? Because if it is, then it follows those there. So questions on this here so far? We good with this here? Okay. How about letter B? Y is equal to x minus 4. What do we think? Why is it neither? Why are we saying neither? I agree. Right. What does this have that our other ones don't? Subtraction. Because these direct and inverse variations are not going to be really dealing with addition or subtraction. Because they're going to be either increasing or decreasing at a constant rate, a constant amount. Because this here would be a linear equation. It wouldn't necessarily be our direct or inverse. Letter C. What do we think here? Y divided by 2 is equal to x. I would agree. I would agree that this is direct. Now this is kind of a little bit harder to see because we have, I'll extend the page out a little bit, because we have y over 2 is equal to x, yes? Well, the two ways that we have it, or we've seen y is equal to a times x, and y over x is equal to a, yes? Well, here I have y and 2 kind of connected together, so that seems a little weird. So what I could do as well, I can do what? I can multiply both sides by 2, because 2 and 2 would cancel, leaving me with y is equal to what? 2x, yes? Well, I can look at it a different way. Is 1/2 times y the same as y divided by 2? Well, yes, I just moved the y to the side, yes? 1/2 y and y divided by 2 are the same thing. So would this here still be considered direct? Well, yes, because direct variation is saying that a term is equal to a constant times the other term, because as one increases, the other increases, yes? So even though the 1/2 is connected with y, we're still using the same operation. I've just kind of switched the values of x and y. Does that kind of make sense? Because x and y don't have to be the y-axis and x-axis. We can still consider them two different things. But normally we would consider y and x to be separate. Y is up and down, x is domain. All right, how about number 1? On this here. Very nice with that one, because that actually is exactly as it's written. Ax equals y. How about number 2? Inverse, our yx equals a. And the last one is? Neither. The plus sign kind of gave that one away, didn't it? Any questions on this here? Okay. I feel like we've got a handle on that there, yes? Okay. Now this is where we're going to stop for the day. The other hour, I did finish this up, but we'll do this and the last part, because there's only 3 parts to this, tomorrow. Now, for those of you who have finished the test and have finished all the assignments, I'm going to give you a hint here so that you can kind of look at this and figure this out, see if you can get to it. This direct is going to be using our y for x equals a, and our inverse is using our y times x equals a. So we're going to be using these two here. There's a specific reason I had to set these up at the beginning to solve these. And we're going to start with this tomorrow. Okay?